Hi, my name is Lynn Weyn, and my project partner is Kyung. Together we worked on the project NaturePill, producing a multisensory, realistic and relaxing virtual forest environment. Nature has numerous health benefits and has been prescribed to relax and reduce stress, aptly called by some as a nature pill. Thus, it is important to have access to nature, but there can be restricting factors such as distance or mobility impairments. Virtual nature is a substitute that provides these benefits, and we created a multisensory virtual forest environment that incorporates the best environmental design to maximize relaxation. By including interaction and exploration in a multisensory environment that allows users to experience the auditory, haptic, olfactory, and optical stimuli, the user will feel more immersed in the virtual environment. Additionally, as it is more closely resembling a real nature environment, the benefits of real nature can be better captured.
These are the research questions we answered regarding the design of this environment. 1. What is the best environmental design to incorporate each of the senses? 2. What elements should we model in the virtual environment in order to maximize relaxation? 3. What is the most suitable locomotion technique for a natural environment given the challenges of a fixed element in the scene, maximizing immersion while minimizing cyber sickness? We will look at the answers to these questions. Here you can see an overview of the final design choices of the environment we implemented. There are two components to terrain design. First, the composition of the terrain, or how the terrain will look with respect to its elements. Second, the elevation of the terrain, or how the terrain is shaped. The terrain was created with beech trees and debris placed throughout the forest. Variations in the terrain is preferred over flat terrain, but navigating large variations in height in VR is associated with a high chance of nausea, and we included most of the terrain variation in the non-explorable areas. This is an image of the aerial view of the terrain. The river and waterfall can be seen, with hills on the far side across the river. For the creation of the forest environment, one of the most important elements are trees. We chose the best Unity assets for tree models we could find, and these happen to be beech trees. While they are not endemic to South Africa, there is a tree called the Cape Beech that resemble beech trees, and we redeemed these tree models to be suitable for the familiarity requirement. To model the sky, clouds, and other celestial objects such as the sun, we use the Skybox, which is a box enclosing the virtual environment. Skyboxes have a single texture mapped onto it and have the properties of being unreachable. Thus, they are very suitable for drawing objects at infinite distance where parallax would not be an issue. Based on research supporting blue spaces stating that they are important to promote mental health, we chose a wide, slow-flowing river. Low flow and low turbidity are preferred in larger rivers, so slow-flowing, non-murky, reflective water is what we found was most suitable for our environment. We found that complex environments are more preferred and restorative over simpler ones, which motivates the addition of details such as rocks, branches, and grass around the riverbank. We chose to add a waterfall to make the environment more complex and interesting. Here you can see an overview of the final design choices of the environment we implemented. We suspect that including other senses such as sound and smell would help provide a more immersive experience. We used petrichor, forest, and undergrowth scents in the experiment room.
We added various sounds to the environment. Wind sounds to go with the gentle swaying of the trees. Morning songbird sounds to give the impression that there were birds in those trees. River and waterfall sounds, given a 3D audio effect so that it is louder when closer to it. And teleportation sounds to give auditory feedback of the success of the teleportation process. We wanted to incorporate elements of touch, so given the constraints of what we can do in a 3x3 meter real room, a bench and a branch were chosen to be present in both the physical room as well as the virtual environment. The branch can be held, and while the user feels its texture, can be used to help move around the environment. The bench can be sat on when in a particular area of the forest. This allows the user to feel its texture while taking in the forest ambience, as one would in real nature. Next, we will discuss locomotion techniques, used to move beyond the bounds of the physical room. The locomotion technique chosen must be usable to align to the bench, since there is a physical bench in the real room at all times, but it's only visible virtually when the user navigates to certain points in the scene using the locomotion technique. To align exactly to certain points in the scene requires a certain level of precision in locomotion, which most techniques cannot provide without causing nausea. There are many different existing locomotion techniques, but we needed one that would be most immersive and realistic, allowing for the alignment to the bench and is not nauseating. Based on past research and what made sense given the context of our environment, we implemented two alternative locomotion techniques that the user can switch between: teleportation and arm swinging. To teleport, The user can press the top trackpad button to span an arc from their virtual hand to where they will teleport to. When the user lets go of the top trackpad button, the screen fades out of their previous virtual location and fades into the location they were pointing to. When the user wishes to use arm swing locomotion, they can hold down both trigger buttons and swing the remotes in order to move into their view direction. A real branch was found in nature, modeled in Blender, and placed in the environment. The branch's real motions are mapped to what can be seen in the virtual environment using an HTC Vive tracker. Teleportation uses the branch if the tracker is more than approximately 60 centimeters above the ground, upon which the teleportation arc spans from where the branch ends to where the user will teleport to. Similarly to teleportation without the branch, the arc appears when the user holds down the HTC Vive controller's top trackpad button with their other hand, and when they let go, they will teleport to where they are pointing to. The user cannot hold the branch while arm swinging, since both trigger buttons need to be pressed on the controllers to arm swing. In order to align precisely to the bench, the user can teleport to fixed teleportation markers in the scene, each placed near a transparent bench. Once they teleport there, the virtual bench will become opaque to indicate that the bench is ready for sitting. When the user moves away from the bench virtually by teleporting or arm swinging, a transparent bench is placed there to indicate that it is no longer correctly aligned. The user cannot align to the bench with arm swinging due to the lack of precision it provides. Since there is a real bench in the physical room at all times, when not aligned with the bench, the room boundaries need to be in front of it so as to prevent collisions and potential injuries. However, after teleporting to the dedicated markers, and so aligned with the real bench, we want two things to happen. Firstly, the boundaries need to extend to be behind the bench to indicate that it is now approachable. And secondly, when sitting on the bench itself, we do not want the user to be able to see the grid as it would reduce immersion. We had to make our own system to implement all this functionality.
When rendering the environment, there needs to be a balance between graphics quality and efficiency. For realism, we used HDR, appropriate light and shadow settings that resemble reality, and AntiAliasing techniques to make the graphics look less jagged. For optimization, we relied on frustum culling, single-pass stereo rendering, level of detail, textures, and baked lights. As part of the balance between realism and performance, we had to choose an anti-aliasing technique that is performant and still visually pleasing. We tested 4 anti-aliasing options and found that fast approximate anti-aliasing was the best option. In terms of performance, there is barely a difference between the average FPS of fast approximate anti-aliasing and no anti-aliasing. The suitability of our design and the created environment were confirmed through heuristic evaluation to see whether these research questions were successfully answered. The heuristic evaluators have agreed the environment had the properties of being relaxing, the visuals realistic, and there were no noticeable latency and frame rates, which are important factors that influence cybersickness. Final heuristic evaluation was done on the HTC Vive Pro VR headset using HTC Vive controllers, and the design and development was done with this device in mind. Here are a few things we suggest for future research. 1. Add a button to the branch for ease of use. Currently, the branch cannot be used by itself independent of the controller. 2. Find a way to align the bench with arm swinging. 3. Visual improvements for the environment could be gained through the use of volumetric lighting, volumetric clouds, and volumetric fog. 4. Further investigation could be done to check if it would be feasible to implement cutting-edge anti-aliasing techniques such as TLSS, which uses artificial intelligence to increase graphics quality while reducing computation time, or a true texture transparency anti-aliasing method such as TAAA, which would enable us to handle alpha-blended textures for the tree foliage better. 5. For the testing procedure, there needs to be proper evaluation methods that survey a large number and more diverse group of people using more formal statistical methods. In summary, key features of the environment include natural scene created with trees, clouds, river, waterfall, and textured terrain with a bench and a branch. It is multisensory with sounds and scents that are encountered in forests, where this environment has been realistically rendered while keeping a balance between performance and quality. This is a full-screen image of the environment seen from one of the benches. Hope you enjoyed our presentation. Thanks for listening. Goodbye.